Hello, this is Professor Jim Caffey, and this is the lecture video for Astronomy, Chapter 1. And we will be doing these every chapter for every module. So let's go ahead and jump into the PowerPoint. Chapter 1. We're going to take a tour around the universe here. And what we first see is a group of distant galaxies, two of them colliding together. And when galaxies collide, they don't really collide like cars do. They kind of merge into a morph of each other. This is two spiral galaxies, kind of like the Milky Way Galaxy, our home galaxy, and this is a Hubble Space Telescope picture. Here we see the red planet Mars in mosaic, and this is centered on Mariner Valley. Mariner Valley is this long canyon through here, and this canyon makes the Grand Canyon on Earth look tiny. This one would go all the way across the United States and be about 6 times deeper than Mariner Valley, than the Grand Canyon. Next up is a stellar corpse. This is what happens when a massive star explodes and dies, and this is the Crab Nebula, seen in 1054 by the Chinese, and we credit them to be the first observational astronomers. And all this bright stuff is the gas and the heavy elements formed inside that massive star, the calcium, the iron, and all that becomes what we see in our body, in our bones, in our blood. Calcium, iron. Next up is I think the most beautiful thing in the entire night sky, and that is the Orion Nebula. In the constellation of Orion, this is a star birthing region where stars are born. And we talk about stars as they're born in the forms of human lives. They're born, they live their lives, they get old, and they die. The Orion Nebula is about 1,400 light years away, and I used to do some really innovative research on some of the stars right here in the middle of the Orion Nebula. This is our venerable Hubble Space Telescope, put into space in 1990. It's going to be replaced soon. The James Webb Space Telescope is its replacement. And the Hubble Space Telescope was named after Edwin P. Hubble, an American astronomer, born November 20th, 1889 in Marshfield, Missouri, which is just a few miles away from me here in Springfield, Missouri. We have an interstate named for him, we have schools, and they have a 1/3 scale replica of stainless steel put onto the town square in Marshfield, Missouri. Here is our home planet, what astronomer Carl Sagan termed the pale blue dot, humanity's home base. This image is 22,000 miles away from the surface from a geostationary satellite. This is where we put our communication satellites, TV broadcast satellites, and weather satellites, because they appear to go above the same point of the Earth as the Earth rotates. It stays above the right place and has an orbital period of about 24 hours. If we were to scale the Earth and Moon together, this is what we would see, how far apart they would be and about how big they are. Our entire solar system family, we have the 4 small planets, Mercury, Venus, Earth, and Mars. 4 gas giants, the Jovian planets, Jupiter, Saturn, Uranus, Neptune. And then some dwarf planets like Pluto. Ceres used to be an asteroid, used to be the biggest asteroid, now it is a dwarf planet, whereas Pluto used to be the 9th planet. It got demoted, and it is now a dwarf planet along with some other dwarf planets. This is a spiral galaxy, probably a borrowed spiral galaxy. There's a bar going through the middle of its core here. And what we see is the bright areas of blue and white are gas and stars being formed, and then the dark stuff going through the middle here is lanes of dust. So gas and dust is what makes up the ingredients to make new stars. A neat image here, a long time-lapse image of the Milky Way Galaxy. And from city lights, we don't see the Milky Way hardly at all. It's kind of hard to see it here in Springfield, Missouri, but I know out there in the desert of Arizona, it's just beautiful. I've been there and done research at Kip Peak National Observatory south of Tucson. What an amazing sight. Of course, if you're in downtown Las Vegas on the Strip, you're not going to see this. This is a globular star cluster. globular star clusters have 250,000 stars in them, 250,000, and they are spherical in shape. They're globular. They look like a basketball. These are very, very old stars that surround the entire Milky Way Galaxy. We can look at galaxies by looking at millimeter light and not light, but radiation. We can look at cold hydrogen with 21 centimeter radiation, and we can use radio telescopes to do that. So here is a group of radio telescopes in Chile looking at some nearby minor galaxies to us, the Magellanic Clouds. The nearest galaxy to us, the spiral, is the Andromeda Galaxy, the Great Andromeda Galaxy, a borrowed spiral, 2 black holes, 400 billion stars. So it is twice the size of the Milky Way. And honestly, the two galaxies, the Milky Way and Andromeda, are coming together. Most everything in the universe is flying apart, getting further apart. But our galaxy and that galaxy are moving together, and someday they will collide. But it won't happen during this course. So we've got that on our side. This is the Fornax cluster of galaxies. This cluster of galaxies is 60 million light years away. So that light left that cluster 60 million years ago and is just now getting here. So around the time the dinosaurs died, that light left and it's just now got here. And so this is what we call look back time. We can look back in the history of the universe to see how galaxies used to be. And everything in that picture there is a galaxy. And if we were to take the entire time frame of the universe and look at it from inception, from the Big Bang to today, where would things occur? Well, the Big Bang happens on January 1st. The Milky Way doesn't form until May. Our solar system begins to form around September. The first complex life forms are in November. And then the dinosaurs came on Christmas Day on the 25th of December, and they became extinct on the 30th. And then on the last day, near the last few hours, humans appeared. And we thank you for joining us for this video lecture.